Hello and welcome back to the video lecture series on statistics for machine learning. I'm Amit Kumar Das, and we are going through the measures of dispersion. So as we have already discussed, two very important measures of dispersion. The first one is the standard deviation, where basically we measure the standard deviation as a summation of xi minus x bar square, where xi represents the values of the different observations, and x bar is basically the mean, as we have already seen in one of the earlier lectures. So summation of that uh, uh, divided by n, the number of observations, and the whole root over, right? So root over of 1 by n summation of xi minus x bar square. That is the standard deviation, which is represented by the symbol sigma. And we have also understood that mean deviation, there is one more measure which is known as the mean deviation, which is measured by the formula 1 by n summation of modulus xi minus x bar, right? So we have already seen how to calculate the xi minus x bar and the xi minus x bar square. So if the same thing we repeat it with a mod value here, we can get the value of the mean deviation, right? So that is one thing that we can do. The third type, I mean, there are many other types of measures for dispersion, but the third popular one is known as the quartile deviation. So quartile deviation, as you can see, the name has a quartile element involved in it. So first of all, before we understand what we mean by quartile deviation, let's try to understand what we mean by a quartile. So for that, let's again just look at a set of observations. So let me put in the values of the observations in a pretty much ascending fashion, right? So I put in the values and let it represent whatever. I mean, any specific variable it may represent. Let's not bother about it too much. Just let me put in a few variables here, okay? And the values. So let me put in some 3, 6, 8, so 12 values. So let me put in 22, 25. Again, I put in 27, 26, and 29 maybe. Okay, so there are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So one more I need. So let me put in the value 31. Okay, now what is quartile? Let's understand that first. So we have already seen what we mean by median, right? The central value. If I just arrange it in an ascending order, I get the central value, and that basically represents the median. So here it might be one of these two values, so average of these two values. So if I just put in a sequence number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I don't need this one. So let me just strike it off. So 12, right? Now, 12 divided by 2 is 6. So I may think that the sixth value is the median value, right? I mean, again, we have already had that discussion that if the total number of observations is even, then we need to calculate in one fashion. If it is odd, we have to calculate in a different fashion. So let's not bog our mind into that. Let's just think that the middle value is the sixth value, right? So this is the median, right? 70. Now, same way, quartile means the whole set of values if I divide into 4 parts. So first 3 parts are this one, second 3 parts are this one, third 3 parts are this one, and this is the fourth 3 part, right? So this is the minimum value, this is the maximum value, right? Now this third value is the first quartile, okay, or the Q1 as we say, okay. The second, the middlemost value is the second quartile or the median, right? Second quartile or what we call the median, right? Then this one, this ninth, this is the third quartile, right? Or the Q3, right? So this is the Q3. Now, what do we do to find out the quartile deviation. So the formula for quartile deviation is pretty straightforward. What we do is half of Q3 minus, so Q3 minus Q1. Okay, so what is the value of Q3? Here we see that the Q3 value is 3, sorry, Q3 value is 22. So 22, okay, minus Q1 value is 11. So minus 11, okay, minus 11, and then divided by 2. So 22 minus 11, I'm sorry, this one, the writing is not that great. So just pardon me for that. So 22 minus 11 is 11 divided by 2, which is 5.5. That is my quartile deviation, right? So this is the formula of quartile deviation. Half of Q3 minus Q1, that is the quartile deviation. And very much related to this, there is one more thing that we often see, and we will see in the next lecture itself. There is something called IQR, or the interquartile range. What is that thing? That is nothing but just the Q3 minus the Q1. So quartile 3 minus the quartile 1 values. That is called the interquartile range. So it is basically twice the mean deviation, or in other terms, mean deviation is twice the interquartile, sorry, half of the interquartile range, right? So this is all about the different measures of dispersion. The first one is the standard deviation, and the squared of the standard deviation we called variance, right? The second one is the mean deviation, and the third one is the quartile deviation. These are the three most standard measures of dispersion that we generally use in machine learning. And one more thing that we commonly use, and we will see in the next lecture itself, or one of the next lectures, is the interquartile range, or the IQR. That's a very important measure, and we will see about that. Okay, so I hope that you have understood how we can measure the dispersion of a particular set of observations, or in the machine learning jargon, we call it the dispersion of an attribute in the data set, right? So next couple of lectures, what we will see is we are going to also see about the practical implementations of these particular measures, the measures of central tendency and the measures of dispersion, okay, and how to do it using Python as a tool. Okay, so stay tuned. Thank you very much.